we are going to know about Michael and Menten equation describing how the rate of an enzyme catalyzes the reaction depending on the concentration of the substrate. So it is a fundamental in enzyme kinetics. So first we will write a reaction. So first we will add the enzyme plus substrate, which will give enzyme plus substrate, enzyme and substrate, that is enzyme substrate complex. So this complex is formed when we will further, this will give enzyme plus product. So where here there is a key one. When enzyme plus substrate is giving us the enzyme and substrate complex, at that time the rate constant form of our ES is K1, and uh, the rate constant for dissociation of ES is K minus 1. Whereas when enzyme substrate complex is forming the enzyme plus product, at that time K2 is use, and that K2 is the rate constant for conversion of enzyme substrate to the product. So now let's know step by step derivation. Write the rate of formation and breaking down the enzyme substrate. First, the formation of enzyme substrate, where the rate form will give K1, then enzyme and substrate. Whereas if rate is breakdown, it will give K minus 1 enzyme substrate complex plus K2 enzyme and substrate complex. So now we have to solve this. So we will solve this. We will apply the steady state assumption. What is the steady state assumption? The concentration of enzyme substrate remain constant over time, and that is the rate of formation of enzyme substrate equal to the rate of its breaking down. So the steady state equation, first we have to write it K1 here, enzyme, then substrate will give in bracket K minus 1. Now what is K minus 1? We will know what is K minus 1. That is the rate constant for dissociation of the enzyme substrate, plus K2 and ES, that is enzyme substrate complex. Now what is K2? K2 is the rate constant for conversion of enzyme substrate to the product. So this is we apply it for the steady state assumptions. Now let's solve for enzyme substrate. So we have to solve it like enzyme substrate will give Q1 enzyme substrate upon K minus 1 plus K2. This is the equation for that. Now let's define the Michael constant, that is Km. So Km will give K minus 1 plus K2 upon K1, that will further give enzyme substrate complex, and that will further give enzyme substrate upon Km. So this was we were defining the Michaelis constant Km. Now let's know about the expression in terms of the total enzyme concentration. So let E0, that is to be the total enzyme concentration, that will be giving us enzyme plus enzyme substrate, and which further give us enzyme and your enzyme minus enzyme substrate complex. So substrate E, we are converting the enzyme into enzyme substrate equation. So for that, enzyme substrate will give enzyme minus here enzyme substrate whole bracket, and So we are going to substitute the enzyme into the enzyme substrate equation where ES. So let's substitute the enzyme substrate here. It will be giving us enzyme minus enzyme substrate complex, and here substrate will be present upon Km. So this is the equation. Now we have to solve it for enzyme substrate. So enzyme substrate complex, here Km plus substrate, it will give us enzyme, here substrate, which will further give us enzyme substrate complex. Now we have to solve it again. We have to add here S, that is enzyme substrate upon Km plus S. So let's define the reaction velocity. So V is equal to D. Here we are using some derivative like d upon dt, and where K2, here enzyme substrate complex will be forming. Then we have to substitute ES, that is V is equal to K2 E0 S upon Km plus S. So let's define the Vmax. So Vmax will give K2 epsilon, here E0, which will give V is equal to Vmax, here substrate, upon Km plus S. So let's the final Michaelis-Menten equation, we got it, and let me know if you need some more explanation. So what do we learn till now? Like step by step we have known the enzyme is a worker, substrate is like a raw material, and product is the finished item. So enzyme complex is worker holding a raw material and working on it. So Vmax is a maximum number of products all workers can make per minutes if they are working at full capacity. So Km is the substrate concentration at which the speed of the production is half of the Vmax. So what's happening in the reaction? The process has three main steps. First is the enzyme binding substrate. It forms the complex. So enzyme plus substrate will give the enzyme substrate complex. Then the enzyme complex can either full apart back to the E plus S, that is enzyme plus substrate. So it will give a product. So steady state assumptions, at some point the rate of forming the enzyme substrate is equal to the rate of breaking it down. So the concentration of enzyme substrate become constant. So what do we need in the Michaelis-Menten equation? To know how fast reaction will happen for any given amount of a substrate. So the final equation what we got is here, V is equal to V max S upon Km plus S. So V is the reaction rate, E is the substrate, here S is the substrate concentration, V max is the maximum rate, and Km is the substrate concentration at which the V is equal to V max upon 2. So what does this tell us? When S is very low, that is substrate is very low, at that time V will be directly proportional to the substrate. Whereas if S is equal to Km, if substrate is equal to the Km, then V is equal to V max upon 2. And when S is very high, that time the V is equal to will be approximately the V max. So this was all about the Michaelis-Menten equation. Thanks for watching. Do like, share and subscribe.